Welcome back. This is the second video for lesson 3.1. And we're not starting at this particular example, but I wanted to show you some data that we sometimes get. Sometimes we get data that's been grouped, and we saw this when we were visually looking at graphs in chapter 2. We saw grouped data. So this question is how hours teenagers spend on video games. So at this point, we don't know the raw data. We only know that there were 3 teenagers that spent between 0 and 3.5 hours on video games. There were 12 teenagers that spent between 7.5 and 11.5 hours on video games. And so if I want to find the mean of this data and I don't have the raw data, I have to have a way or a number, because it's numerical, I have to have a number to represent each of these groups, shall we say. So we are going to learn how to find the mean for grouped data. And if you go to page 40 in your course pack at the bottom, I am going to teach you how to find the weighted mean and the mean of grouped frequency tables. So the directions are the same, they're just called two different things. Okay, so when you have a large data set that has multiple values with repeats, grouping the data and calculating a weighted mean can be time saving. That's going to occur on the next one. So put the data into a table with the first column being the possible data values. You'll see on page 41 that I've done this with this data. This is we are revisiting the transplant data, how long a patient waits on the transplant list. And if you remember correctly, I think there were 39 data points, and it took a while for me to type those in. You didn't see me type them in, but it would take a while. And you could see we had several repeats on the 7s, the 10s, 19s, and so forth. And so what I did was I made a table, a data value of each possible data value, and that here in the frequency, I put the number of times that each of those data values occurred. So 7 occurred 4 times, 10 occurred 5 times. This is a quick way to find your mode, by the way. And so I tallied up my frequency and I validated that I did have 39 data points here. And then the third step would be the third column will be the product of columns 1 and 2. So I'm going to take column 1 and column 2 and multiply them to get column 3. And what that does is that tells me if I were to add up the 4 7s that I had when I go to find the mean, right? I have to add up all of my data values. But if I wanted to add up all those 7s, I have 4 7s. So 4 times 7 is 28. So 28 is the value of the 7s. So by finding each of these products, I can then add this column and it gives me the total of all my data values. So let's write that here. Total of all data values. And then I can take that total and divide by the count, which is 39, and I get the mean of 13.95, which is exactly what we had in the earlier part of 3.1, and that's because we had the raw data. Okay. Now, calculating the mean of grouped data is essentially the same thing, except for now we don't have raw data. We don't have all the raw data values, but I'm going to go through a similar process. So we are going to group the data. So our first column is the classes that have already been predetermined values with a lower bound and an upper bound. And we learned how to do that in chapter 2. So I showed you that. This is the number of hours teenagers spent on video games. We've already found the lower boundaries and the upper boundaries, and we've already told the reader how many teenagers fall into each of the groups, into the classes. Okay, since we do not know the individual data values, we can instead find the midpoint of each interval. That gives us the data value. It gives us a value that will represent each of the classes. So we're going to use the midpoint. So we can take the lower boundary plus the upper boundary and divide by 2, or if the upper boundary is a decimal, it may be, this should just say it may be simpler to use the lower boundary of the next class. So the midpoint would be the lower boundary of the current class, but the lower boundary of the next class. So it just depends on what type of data that you have. We're going to go through an example, don't worry. Then in your second column, you're going to put those midpoints that you just calculated. The third column will be the frequencies of the data that fell into the classes that you were given. The fourth column is going to be the product of columns 2 and 3. So similar to what we did on the prior page. Then you're going to add up all of those products for column 4 and divide by the total number of data values in column 3, your frequencies. And then the result is your weighted mean, or the mean if you would have used the original large data set. Okay, so let's look at what we have here. So example 5. So if we want to find the midpoint, we're going to take 0 plus 3.5 and divide by 2. Now, the upper boundary is the same as the lower boundary, so this is the same strategy. So this is going to be 1.75, and then we're going to take 3.5 plus 7.5 and divide by 2, and that's going to be 5.5. And then we've got 7.5 plus 11.5 divided by 2 is 19. And so when we divide by 2, it's 9.5. And you can see we have now a pattern of there is a difference of 4, a difference of 4, and a difference of 4. And so we should be able to add 4. So if we add 4, we get to 9.5. If we add another 4, our next midpoint should be 13.5. And then adding 4, we get 17.5. So then we're going to take column 2 and multiply it by column 3 to get column 4. So 1.75 times 3 is 5.25. And then 5.5 times 7 is 38.5. 9.5 times 12 is 114. 13.5 times 7 is 94.5. And then 17.5 times 9 is 157.5. And if we take 157.5 and we divide by our total, so if we add these all up, we find out there were 38 of them. And so if we divide by 38, we do get 10.78. So now I would like you to try example 6 on your own. And when we come back, we'll go through it together. Okay. So calculating your midpoint, you should have gotten 54.5, 64.5, 74.5, 84.5, and 94.5. And then when we multiply each of the midpoints times the frequency, we would get 109, 193.5, 596, 1014, and then 472.5. And then when you add these up, you get 2,385 divided by our total frequency, which is 30. And that comes out to be 79.5. Is the average grade. Excellent. Pat yourself on the back if you got that. Okay. Now that we know how to find the mean, median, and mode, and thinking back on chapter 2 with our graphs, you might be asking yourself, how do we know which um, is the best measure of center? And how would we describe the shape of our distribution? And how do those go together? After we did talk about symmetric and skewed left and right in chapter 2 with our graphs. And so we can make some decisions on this, and it's usually choosing between the mean and the median. So if our data is skewed visually, that is telling us that numerically our mean and our median are equal or approximately equal. In that case, we're choosing the mean. If you've only been given the numerical values, you're looking to see if they're equal or approximately equal. And some of that is a little subjective depending on the type of data that you have. Now, if your data is comparing your mean to your median, notice my mean is always on the left because MEA is alphabetically before MED. That helps us remember. If you always compare your median on the left to your mean on the left to your median on the right, you can make these decisions. So if the mean is less than the median, then that tells us our data is skewed left. In that case, we're choosing the median. If the mean is greater than the median, our data is skewed right. The arrow is pointing to the right. Then we're also going to choose the median. So if our data is skewed at all, we're choosing the median as our best measure of center. And if our data is symmetric, we're choosing the mean. So let's look at an example here. Example 7, I don't have a context. I just have some data for you to look at. I want you to find the mean, median, and mode and come back, and then we're going to decide if the data is symmetric or skewed and what is the best measure of central tendency. So go ahead and pause the video and make your decision. Welcome back. Okay, so calculating here, I get the mean is 20.56. The median is 22. The mode is also 22. And so we have to decide what is the best measure of center. Now, comparing the mean to the median is 20.56 compared to 22. And this is definitely less than 22. However, they're pretty close together. If you look 16 to 23, it's only a difference of 7. I think we're going to go with approximately equal here. So we're going to say it's symmetric. And because it's symmetric, we're going to choose the mean. Okay. Let's look at another. Example 8. We have earnings of non-living celebrities. So celebrities that have passed away. And what is that telling us here? So that means that like Michael Jackson, he passed away, but he's still earning money because his music is still being sold. He's not even on this list. Bob Marley is still making money, royalties and earnings. So this is, I'm guessing maybe in millions a year. It does not give us that. Kurt Cobain, 50. Okay, so we have the list here, Forbes list, and I put these into Desmos and says find the mean, median, and mode. So the mean is X bar. And I come up with 19. And the median, I come up with 10. So it's definitely skewed right. And that's probably because we have a couple of people that are making much larger than these lower 3 here. And so that means our median is our best measure of central tendency. Our last example for lesson 3.1 is example 9. So example 9 says, discuss the mean, median, and mode for each. And so here are some graphs to kind of go over this again. So this is the 2010 Winter Olympics gold medal wins by top 20 medal winning countries. So this would be the number of countries that scored this many gold medals. So there was one country that scored 14 gold medals. There were two countries that only scored 0, four that only scored 1, or earned 1, I should say. So if we look here, I would say the center of the data is here, and then it definitely trails off. So this would be a skewed right data set. Now, the next data set is the ages of former US presidents when they died, the age of when they died. Now, it's in a stem and leaf plot that we learned how to find in chapter 2, but I'm going to look at it this way because I visually I get the distribution better this way for myself. And this, I'm going to take it up, and I'm going to take it down, and it looks pretty symmetric to me. And then we have this data set here, hours spent playing video games on weekends, the data that we've already looked at numerically. And whoa, it definitely looks skewed left. And let's go back and look at that data. We didn't have the raw data, but you can see here that there were definitely just a few that were over here. The majority was in this area. And so I can see where that was skewed left. And that is all for lesson 3.1 and the best measure of center. And we're going to move into lesson 3.2 next. Catch you then.